Okay, welcome to our talk about the Quad-Copter. Well, your professor right here. I'm just introducing the quad.
Do you want to introduce yourself?
Yeah, my name is Burke. Yeah.
Okay, should we take a look? Okay, so here is the quadcopter we're going to be modeling. It's a very small, very light. We'll be flying it in a minute, but
It might hit the ceiling.
this is the remote control for it. Okay, and so let me see. This I can only bend up and down, so this is like going to be our step input. We're just going to go.
That I'm not going to be doing because I do not want to bring it on the ceiling. So I'm going to go like this.
Okay, well, hold on. So this is the one we'll be modeling because that just goes up and down, and that will then spin all four of the propellers, I guess at the same rate, so that it
They all
should go
go
straight
up.
up. Now these little things here, actually I don't know which ones, but these two controls here allow you to like change the basically the zero level, so that because these things, you know, they can be bent a little bit, and as they do, the controls need a little bit of the remote control here needs a little bit of adjusting to make sure that when you want it to just go straight up, it can go straight up. Well, because of the bending, if you see it start, moving this way or that way, you kind of adjust these to be, well, if this is right in the center, then this goes straight up. Because this one then moves in all directions, and that will then allow you to on a elevation, a constant elevation plane, right? By go up to a constant elevation, it then you can then use this lever over here to do differential motions in the propellers to turn left or right, back, whatever. And so that's why there's two joysticks there. But this one I can't, wait.
You just figured something out.
Well, either way, yeah, see this, okay, that's what it is. This one goes up and down and stays there. This one, if I push it up, it springs back. So either way, this one is used for just up and down. I think it's just it gives you left and right motion here. I don't think the left or right motion does anything. It's just the way it's designed. So any up and any down. Anyways, this is the one we're modeling. It just goes the up and down. And by just pushing it a little bit upward, right, we will give a signal.
It will go rocketing up.
We will give a signal inside here to like the electrical circuit. It accepts the electromagnetic signal sent from the controller to say, hey, give it some voltage. So connect the circuit, give it a voltage, and if we put it up and keep it up, it'll be a step voltage. So from nothing to something, and that constant something stays. Now inside here, right, you then have four rotors with, and they're tiny little things, right? Four rotors connected to a propeller that if we're just focused on the vertical motion, the thing will just go up and down. And we can model it as just a single propeller. Well, a single propeller in reality is very unstable and will just duck over. So it's just a model where we are enforcing motion in only the vertical direction. Okay, so we're going to see how that works in practice. Now,
Dad?
think about how, since we're using the remote control, our brains are the control system. So if we want to go to a constant elevation, maybe we give it a step input, but if that's not working, we can, what we're going to do in the video is give it a constant, we give it a constant voltage. We want it to get to a constant elevation by doing that. And if that's not accurate, if it's not behaving the way we want, then we need to adjust the controls continuously as we sense the height of the controller, we make adjustments to our input. So in that sense, our brain is the decision maker, our eyes are the sensor, our brain is the decision maker, and our finger here is then modifying the actual signal that goes into the dynamic system itself.
Dad?
Yes.
Do you know what this is for?
Yes, I do.
What is it for then?
Well, that is the on-off button. Okay, so let's turn it on and we'll give it a go.
Okay.
Okay, so let's fly this thing. I got everything turned on. the quadcopter synced up here with the remote, which takes a little bit. But what I'm going to do here in this video is I'm just going to turn this as a step input. So we're going to give it the throttle to a steady position. I'll make sure it's enough to have this thing fly and overcome gravity, which we actually neglect in our analysis. Later on in this, a later step, you know, not immediately we'll include gravity, then we neglect it halfway through. But we'll give it a step input here, and I'll just let it go, and we'll see what happens. We'll see what the behavior is. Is it a constant position, maybe a constant velocity, constant acceleration? Let's see. So what we're gonna do on this first go here is have no control system, meaning I'm just gonna give this a step input, right? We got the quadcopter linked, that's why all these lights are on with the remote control. So I can give it an input by just a step input to the throttle here, which means there'll be a constant voltage inside, and like connecting the battery to the actual motor that turns the rotors there. and then we'll see what happens. We'll see what the response is. Is it a constant position as the output? Is it maybe a constant velocity? Maybe it's oscillatory. Let's see what the response is for the system with just a constant input. And okay, here we go. So I'm just gonna raise it up and keep it there and not touch it again, unless it's gonna crash into the ceiling or wall, in which case we might get involved again. Okay, here we go. Ready? Okay, that didn't work, so let's try this again. Again, constant throttle. We're just gonna turn it on to some measure, to some level, and we'll just leave it there and see what the response is. Here we go. Up. We gotta catch it. Oh, good catch.
But you threw the remote.
I did throw the remote. That's pure instinct. Let's try it again. So that just sort of took off on me and just kept going up. See if I can do better camera work this time. Up. Okay, so now in this one, I will try to have the quadcopter here go and maintain a constant elevation. So that is my desired outcome. And to do that, I'm going to be the control system. So my eyes will be the sensor. I will then use, I guess my brain will make the decision on whether we need to give more or less on the throttle, basically increase the voltage inside that circuit. And that'll then send the signal to my thumb on whether to go up or down. And there's a constant adjustment being made here as I am the control system. So I'll try to have my thumb, you won't be able to see my brain, but hopefully we can also record the video. I don't know, maybe this is not going to work. Let's see here. I'm gonna focus on there, okay? Oh, more. Less. Oh, there. See? Constant adjustment. I have to give it a little more. I'm deviating, gotta give it more. Oh, and we failed. So we're able to do it. Let's see if we can get it again, because that actually went well. This is probably like take 15. Let's see here. Do it again. Oh gosh.
Don't hit the ceiling.
Oh man. Okay, I'll try one more time. Every time it falls, like it needs a readjustment of as the propellers get slightly tweaked. Okay, let's try again. That's pretty good. Want to go a little higher than that? A little higher. And we'll drop it. Okay. So I don't know if seeing my thumb, but let's turn it off so I can talk briefly about, right? So I had to just sort of make tiny little tweaks here to try to keep it, like kind of like that was the motion, to try to keep it at a constant elevation. Even then it wasn't that successful. So what we'd like to do is put sensors into this thing to automatically check whether it's changing elevation or holding steady. And if we start, trending upward beyond what our desired steady state is, wherever that elevation is, we would then back a little bit on the voltage, and then we would give it a little bit more. And so the project is all about modeling the system to understand the complete dynamics of it as best we can. And then once we have a model for the system, put a control system in to achieve that desired outcome. So let's talk about a quadcopter that can do that. Okay?
Okay, welcome back. We are gonna be talking about the
autonomous
quadcopter, and it's just the second one. We've already done this one, so
So it's much bigger. It still has those black propellers in there. It still has 4 of them.
This
So
one doesn't have black propellers.
no, it has white. So these have 4 propellers, but it's much bigger. But actually, by weight, about the same weight. If anything, this one's
Really?
heavier. Yeah, I know. It's surprising. This one's very light.
Yeah, this one is light because this one has like a heavier battery, I guess.
Nice.
Or this one maybe just uses it by the charge,
Yeah.
but this one charges the battery.
So the weight, this one definitely has heavy batteries, heavy components. Batteries might be lighter here, or just the electronics are lighter. But regardless, this one is different because of that thing right there. That
What's in?
right there, and it has one there. It has one there.
Those are sensors.
It has one there and one there. So it has 4 of them, and I think it has
Are they
something on the bottom
sensors?
as well. They are sensors. And then it has
How do they see them on your top?
So, and then it doesn't have it on the top. That is good. And maybe it does. Maybe that there. Yeah. No, that isn't one. I think it only has 2 on the side. And, yeah, so it doesn't need one on the top. Okay, that's right. Okay, so let's explain this, right? What it actually does is it's looking down and looking in the back forward, left to right direction. And so that if it ever senses it's getting close to an object, like, whoop, it'll just start turning this way. And then it also looks down. So if it ever gets close to the ground, it'll automatically go up. But that means it never has to look up because it's only going to be, giving it more juice and giving more lift if it's hitting something on the bottom. And it doesn't actually need to look upward because it'll assume that there's always room upward to move, right? So it doesn't.
No, but then it will hit the ceiling.
But that's the thing is it'll go up a little bit and then be happy, and it automatically will find a constant position above the surface below it, right? And so then if it comes from this surface over to here, it'll actually lower down to here and find maybe with a little oscillation, a place there, and then it comes over to here and it finds to the ground another place. And so we'll see how that works. But so there's a built-in control system to give it a constant elevation above the ground. Now it does also have the left-right constant position, so if it gets too close to a wall, it'll sort of backtrack. But that's how this one differs from this, is that here we flew this one, we observed that if we get a step input, it actually just has a constant velocity moving upwards, maybe not our desired output. We want to, when we give it a input of just a step function on the input, that this just goes to a step position change, so it goes to a constant elevation. Well, we can only do that through a control system, and the control system that we're limited to here is us, the human body, the user of the remote control. So we are constantly updating this to get it to, as we observe the system, we sense it with our eyes, we make the decision with our brain to then change, to use our fingers or our body to change the throttle, and we can get it to a constant position that way.
And the elevation.
Yes. This one has it automatically, right? So it's built in with these sensors, trying to get it to a constant position, and that's what we'll be modeling in this problem, in this the project. Okay.
Yeah.
All right. So let's fly the other one.
And you can also just put your hand under it and it'll go up. Or if you want to put it another way, those sensors sense your hand, and it would go the other way off your hand like a wall.
All right. Let's give it a go. Start it up. Look at that oscillation, see? A little, somehow it's raising up, so now it's adjusting. Ah.
3, 2, 1, go.
Do you want to try to put your hand underneath it? All right. So I hope, well, as you can see now, the two quadcopters are charging, and this one ended up taking some damage, and so it's kind of can't be used.
Right at the end of that video, hits a post, breaks off one.
Break the propeller. But you know, we started with the basically the dynamic system of this quadcopter, and that's actually the one we will be using assumed values for. So we're going to be modeling actually this quadcopter in the you know, the homework assignments or the project. And remember we did two things with this, right? First thing was we just gave it a step input, and that just makes a step voltage input into the actual electrical system, which then produced a constant velocity in terms of the vertical position. That's what we observed, right? We then let me, the human body, with the human brain, be the control system with continuous tweaking to try to get it to that desired constant elevation steady state. And we were able to do that with some success, although it was a little bit challenging with the camera recording everything. And then we thought, well, how would we do it for an autonomous quadcopter? Well, that would require putting sensors in there, because instead of the human eye, we will have to have the sensor, you know, photosensors or some sort of light sensors. And then there would have to be a brain, like a decision-making component inside there as well. And then that must then feed a signal into the rotor, or into the electrical system, which then communicates with the rotors, which then communicates to the propellers how much to spin, which then gives it the lift, right? Well, we have that in another model over here. This is an autonomous one. There's no remote control with this one. So this one just flew all on its own and would achieve the constant vertical position with the photosensor on the bottom there. It also has the left to right sensors to make sure it doesn't hit walls. And that worked pretty well too, but we did see some oscillatory motion as this was adjusting up and down, so maybe there's some underdamped nature there. But that's the type of thing we want to then analyze about this system if we were to add kind of some of the components that are already built into this quadcopter system. Okay?
And we're going to finish with some bloopers.
You want to watch some bloopers to finish off the video?
Yeah.
All right. Okay, we'll give it a try here.
Whoa!
Yeah. I don't know why it's not really working.
The sensor broken?
I'm going to be constantly adjusting this thing. I'm not very good at it. Many of you are likely much better. So let's see if I can do it while recording the video. Ready? Here we go. Constant elevation, more. Oh, see? Now it's oscillating up, down. Oh, we hit the wall. Okay. Oh gosh, it headed straight out at me. Why is it doing that, Burke? Jeez.
I don't know.
Make the difference. So I'll try here to keep everything in frame so you can see how much I'm adjusting up, down while recording the video and keeping this thing not crashing. Let's see if we can do it. Oh, that's impossible. It's impossible. I can't do all the things at once. Let's see if I can do better camera work this time. Up, 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 up. Oh gosh, it's on. It's on. Turn it off. It was going in my hands. I forgot to turn it off before I let it drop in my hand. Stop.